When you look at a fresh apple, you are looking at a highly engineered structure. It is a fully formed, three-dimensional biological building. The outer walls of this building are made of tough plant cell walls. They form a rigid, grid-like framework. Their primary job is to act as a secure vault, keeping the plant's intrinsic sugars and nutrients locked safely inside the cellular matrix. Because these sugars are physically trapped, your body has to work for them. During digestion, your enzymes must slowly dismantle the structure piece by piece. This physical barrier ensures the energy inside is released at a steady, tightly controlled speed. Placing that same fruit into a cold-pressed juicer completely bypasses this natural digestion process. We have to look at what happens to the biology of the food when we apply extreme mechanical pressure. The steel blades and heavy presses act like a wrecking ball on a microscopic scale. The rigid, three-dimensional cell walls are instantly crushed into a flat pile of rubble, forcing all the trapped liquid to burst outward. The machine then separates and discards the solid pulp. That pulp is the protective wall. By throwing it away, you strip the food of its physical barriers, leaving only an unprotected pool of liquid. The chemical nutrients inside that cup of juice might be identical to the whole fruit, but the destruction of the plant's physical architecture dictates a different physiological outcome for how your body will process it. When this pure liquid enters your upper digestive system, it encounters no resistance. There are no intact cellular structures left to slow it down. Biologists measure how easily nutrients can escape their food matrix during digestion using a metric called bioaccessibility. Because the juicer already destroyed the plant cell walls, the bioaccessibility of the sugar reaches a 100% immediate release rate. This animation compares the two digestive states. On the right, these unprotected sugars, now what we call free sugars, lack a solid matrix to navigate. They bypass standard digestive delays entirely, flooding into your blood in a massive wave. The resulting data line illustrates high glycemic variability. Instead of steady energy, blood sugar undergoes an extreme spike, triggering a rapid crash. Your metabolic system has to work in overdrive to clear out this chaotic influx. The rapid clearance removes the sugar so quickly that it leaves you feeling exhausted and hungry again shortly after you finish drinking. Nature built the fruit's physical structure to guarantee a slow, steady release of energy. Removing those barriers forces your metabolism to deal with a sudden, unmanageable flood. Further down the digestive tract, the consequences of this missing structure become even more severe. Down in the large intestine lies the core of your gut microbiome. Billions of microbes live here, operating as an essential workforce of downstream builders. To survive and execute their jobs, they require a constant, daily delivery of intact structural materials. Specifically, they need the tough, woody, insoluble fibers and the intact plant cell walls. These complex carbohydrates only survive the acidic journey through the stomach if they remain bound tightly in solid food. By extracting the juice and tossing the solid pulp into the trash, you physically separate the liquid from the structural fiber. The raw materials these microbes require never arrive. A liquid diet arrives empty of structural fiber, effectively starving this microbial workforce. Without their physical food source, the beneficial bacteria diminish and become inactive. A cold-pressed green juice often feels like a healthy choice, yet the mechanical process of making it actively deprives your most crucial internal ecosystem of its foundational biological fuel. When these downstream builders are properly fed, they ferment solid fiber to manufacture highly protective helper molecules called short-chain fatty acids. This diagram highlights a crucial one: butyrate. Butyrate acts as a secure mortar, feeding the cells lining your gut, ensuring they stay locked together in a highly secure, leak-proof seal. When starved microbes cannot produce butyrate, gut wall cells lose their primary energy source. The tight junctions weaken, and the protective barrier begins to fail. These tiny cracks act as structural leaks. As waste products and toxins escape the gut pipeline and enter the bloodstream, they are detected by the immune system. This immune response triggers a state of persistent systemic inflammation as the body attempts to neutralize these foreign intruders. The breakdown of this internal firewall is a direct physical reaction to crushing the three-dimensional architecture of the plant before you consume it. To keep this pipeline secure, we just have to look back at the original uncrushed apple. Preservation works exactly where extraction fails. Chewing and digesting solid fruits and vegetables provides your body with the exact physical framework it requires. The intact cell walls enforce a slow digestion rate, regulating your blood sugar smoothly and naturally. Swallowing those solid, fibrous pieces ensures a steady delivery of raw materials to the large intestine. Feeding your downstream builders consistently guarantees the long-term structural safety of your gut barrier. A nutrition label provides a list of chemical ingredients, but the biological impact of those nutrients is governed by the structural integrity of the plant package itself. By eating food with its natural scaffolding intact, every stage of digestion receives what it needs, maintaining continuous harmony across your internal ecosystem.